Hello, this is my assignment 2 where the topic is lexical analysis, token generation and AST visualization. And my name is Patel GR and my USN is U240E01CS097 and my faculty is Dr. Santosh Kumar sir. So let's start the introduction. So the introduction is a computer program is written using source code and the compilers do not understand source code directly. The source code is converted into different representations. These representations help in understanding the program. So we can also know about the modern AI tools also use the representations. So the goal of this is to visualize the internal structure of a C programming using tokens AST, CFG, DFG and CPG. So this is a sample C programming code where it will be taking the value called x and it will be initializing the value y. If x is greater than 10, then y is equal to 100, else y is equal to 200. So return y. So this is a sample program and the logic of the program is x is assigned value is 15 and condition is x greater than 10 is checked. If true, y becomes 100, otherwise y is 200. So the value will be returned. So lexical analysis. Stage 1, lecture engine. Tokenizing character streams where the rule processing is evaluates lexical character strings using optimized JavaScript regex patterns and the token classification. Automatically divides source components into keywords, identifiers, literals and operations. So the location coordinates captures matching index boundaries to allow highlights syncing with the code canvas. So we can see the diagram where the input source snippet is int main return 0 and the output token is int main the brackets open flower brackets return. So this is the lecture engine form and the abstract syntax tree where it is called as AST engine. So the parsing logical hierarchies handwritten parser employs a robust recursive discrete compiler logic targeting ANSI standards. So the syntax isolation purges unnecessary punctuations, semicolons, commas, braces to focus strictly on operational orders. So the hierarchical map. So constructs a parent-child syntax map linking core function deals to conditions, evaluations, and returns. So you can observe the image here of the hierarchical map where the root node is connected to the function main function and the include stdio.h. So the function goes to inside the block where the block first inside the block first comes the action or a function where the declare is equal to sum. So the after the sum it comes to the a b and the operation plus and return the answers. So there will be given id for that a b and the after the return you will get the sum of this. Next is control flow graph where that's this the stage 3 called as execution pathways representing logic paths maps the computational timeline and branching steps of execution through basic blocks and the node resolutions. The node resolutions groups operations into straight line basic blocks with one entrance and exit point. So the path focuses renders conditionals, loops, if checks as 4-point splits into true or false directional edges. So if you observe in the image, so start main will go directly initializes into int a and next comes to int b. So it will directly after the operation addition, so it will go into the int sum place and it returns the sum and the main program ends over there. So this is the data flow graph. This is nothing but the stage 4 dependency flow. Tracking variable liveness instead of tracking when instruction executed. CFG and data flow graphs maps the structural life cycles and reachability of variable data inputs across statements. So here int x is defined and int y is also defined. Here you can see the diagram and look after that. Definition is identifies position inside code block where a specific value is created, written or reassigned to a memory location And it uses means the use cases are identify positions where a variable data is retrieved or read. So next, if we go to the code property graph, here the stage 5 is integrated engine, unified structural models. Graph fusions is the seamlessly overlays the syntax of AST, the execution logic of CFG, and the variable flows into of DFG into the unified model. The interactive layer toggles include panel switches to active or hide layers selectively depending on the analyzer's query scope. Also, the security standard serves as a premier industry framework for advanced static software auditing and bug classification. So you can observe the diagram you over here. So this is a basic code property graph where you can go in deep into the program that we have written. So the start main is the root thing where it goes into the sum return function main root program processor. So these kind of things happens. So next is the automata and language theory. So here you can observe regular grammars, context-free parser, and fixed point flow. So the inside the regular grammars, we can take the lexical tokenizes converted source characters into tokens using regular expressions mapped directly into deterministic finite automata state groups graphs. And the context-free parser, the C parser evaluates syntactic grammar rules utilizing a context-free grammar hierarchy executed through recursive calls simulating pushdown automata. So the fixed point flow is data flow mapping evaluates structural equivalence inside program. It applies clean fixed point computation to resolve reachability states inside loops. So when we come to AI and large language models representation (LLMs), so in the modern AI application, the teaching machine to scan code attention coordination is modern transformers process sources code patterns by learning token placements and scoped variable dependencies. So the graph is a neural network AI driver scanner converts structured code property graphs directly into the code embedding to detective uh, vulnerability vulnerabilities. So the syntax generation, abstract syntax trees instruct LLMs to maintain valid grammar models during complex script conversions. So next we'll go into the real world applications where it is taint and optimization flow. Auditing and taint analyzers. So this is the leverages joint AST plus DFG tracks to audit if raw user input reach dangerous system calls without sanitization. So the optimization phases leverages controller data property to pinpoint dead statements and safely reallocate variable register assignments. So the educational workbenches declutures heavy academic theory by rendering interactive state models in browser sandbox. So this is all about the 86 second assignment. Thank you.